Today's lesson is graphing linear inequalities. Please get out a piece of paper and title your paper 8.8 Graphing Linear Inequalities and write down the following steps. When you have them written down, you can turn back on the video and I'll walk through the directions with you and we'll do some examples. The first steps for graphing linear inequalities are very similar for graphing lines except for you are going to use either a dashed line or a solid line depending upon the inequality symbol. If you have a less than or greater than without an equal sign underneath it, you're going to have a dashed line. If you have a greater than or equal to or less than or equal to, you're going to have a solid line. So the dashed line will look like this, and the solid line will just be a solid line. So same as graphing lines with inequalities, you first plot the y-intercept and then you use the slope to find 2 or 3 more points, and then you're going to connect the points together with a line, either dashed or solid. Then the third step, which is different from graphing inequalities or graphing equations, is you're going to shade the graph. You'll shade below the line if y is less than, and you're going to shade above the line if y is greater than. So let's look at some examples. So the first example here, we have the inequality y is less than or equal to x plus 2. So to graph this inequality, we first need to graph the y-intercept, which is 2, and then the slope is 1, so we move up 1, right 1, up 1, right 1, up 1, right 1, or we could go down 1, left 1, down 1, left 1, down 1, left 1. And then we're going to connect that together with a solid line because it has the equal to sign on it. And when we connect these points together, I don't know what's going on with this today. Let's try this one more time. I don't know why these lines are doing this, but I'll just delete them quick a minute. Okay, let's just ignore those lines, and so it'll look like that. Now we need to decide, are we going to shade above or below the line? Because it's less than, we're going to shade below the line. So we take our highlighter, you can just take your pencil and you shade below the line because it's less than. So any point on the line, because it's solid, or below the line in the shaded region can be the solution to this inequality. So let's graph the next one. Because there's nothing added to the x, the y-intercept is 0. The slope is -2, which means we're going to go down 2 into the right 1, down 2 to the right 1, down 2 to the right 1, or we could go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. Because we do not have the equal sign, we're going to connect this together with a dotted line. Which will look like this. And we put an arrow on the end. And then we shade, because it's less than, we are going to shade below the line. Whoops, now the graph moved. I guess I need to get my highlighter. Here we go. And we shade below the line. So anything below this line will be a solution. Nothing on the line can be a solution because it is dashed, so it cannot be any point on the line, so any point below the line. Okay, I have a couple examples for you to try on your own. You can you can first graph the y-intercept, which is -1, and then you're going to graph the slope, move up 3 to the right 1, up 3 to the right 1, up 3 to the right 1, or you can go down 3 to the left 1, down 3 to the left 1. And what kind of line are we going to connect this together with? We are going to connect the points together with a solid line because it has the equal to sign. And because it is greater than, we are going to shade above the line. So this would be the solution. Any point on the line and anything above the line would be a solution to this equation. So the second one, let's check to see how you did on this. First graph at the y-intercept, which is -4. The slope is 2, so we can go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, or we can go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. And we're going to graph this together with connect the points together with a dotted line because it doesn't have the equal to sign with it. And because it is less than, we are going to shade below the line. So I'm going to get my highlighter and I'm going to shade below the line. And you can just do this with your pencil or your pen, or if you want to use colored pencils, you can do that too. So that is the solution for the inequality y is less than 2x minus 4. So now we're going to look at systems of linear inequalities, and that's just two or more linear inequalities form a system of linear inequalities. The solution is any ordered pair that makes both inequalities true. So we're going to graph each equation just like we did with systems of equations. So we'll graph this equation first. Y is greater than x, so the y-intercept is 0. And the slope is 1, so we move right up 1, right 1, up 1, right 1, or we can move down 1, left 1, down 1, left 1. And we're going to connect that together with a dashed line because it doesn't have the equal to sign on it. So here is the line, but now we need to decide where are we going to shade. It's greater than, so we're going to shade above the line. So with this here, you might want to use two different colored pencils or make maybe some straight lines for one of your graphs and then horizontal lines for the other graph when you shade, so you can distinguish where it overlaps, because that's what we're looking for, the region where it overlaps. So let's look at the second equation here. Or inequality. Y is less than or equal to -x plus 2. So our y-intercept is 2. We're going to go down 1, right 1, down 1, right 1, down 1, right 1, or we can go up 1, right 1, left 1, up 1, left 1, up 1, left 1. And we connect it together with a solid line because we have the equal to sign there. And then we are going to shade, because it's less than, we're going to shade below. So I'm going to pick a different color for the highlighter. And you can see where it overlaps on the screen because we get kind of a green color instead of yellow or blue. So the region where it's green is going to be the solution to the inequality. And it's this line here that I've outlined in red, and then this dashed line that I outlined in red. And then all of this area in here, which is the greenish color, is the solution to this system. Here's an example I want you to try on your own. You can pause the computer, and when you're ready you can start the video again, and then we'll go over the example. Okay, so first we'll graph this equation here. We start first at the y-intercept -5, 1, 2, 3, 4, 5, and then the slope is -2, which means we're going to go down 2 and to the right 1, down 2 to the right one, or we go up 2 to the left one, up 2 to the left one, up 2 to the left one. And we are going to connect that together with a solid line because it has the equal to sign. And we'll start here. There we go. And where do we shade? It's less than, so we are going to shade below. So I'm going to go back to my yellow marker, and we'll shade below the line. Like I said, with these, you can use 2 different colored pencils, or you can draw horizontal lines or vertical lines with your pencil, or you could use pencil or pen, whichever you'd like to do. The next equation, the y-intercept, there's nothing added to it, so we start at 0, and the slope is 1/2, so that means we rise 1, run 1, rise 1, run 1, rise 1, or let me go back here, rise 1, run 2, rise 1, run 2, rise 1, run 2. So we're going to go down 1, to the left 2, down 1, to the left 2, down 1, to the left 2. And we will connect this together with a dashed line because we have just the less than, there's not an equal to. And because it's less than, we are going to shade below the line. So I'm going to pick another color again so we can see where that overlap is. So we're shading below the dotted line. Oops, I went out of that a little bit. So where they overlap, or where it's green, is going to be the solution, and our border is the line. So we have a dashed line here, so we can pick any points up to, but not including points on that line. And then on this side, we can pick anything on that line, and then we can pick anything that is in this green region would be a solution. So that's today's lesson on graphing linear inequalities, and systems of linear inequalities. If you have any questions, jot them down and bring them to class tomorrow. Have a good night.